All right, we're going to go and get started. If you haven't checked in, please do that. Um, so far, I haven't seen many questions that I haven't addressed. Uh, and if you're unsure, check that discussion board because I was responding to a couple of people. Um, Before I explain kind of what's going to happen today, I emailed you and I put on campus a practice test. All right, it covers pretty much everything we've done in this chapter, and that's it. All right, so sequences, arithmetic, geometric, um, and then what we're going to go over today, which is combinations. Okay, this shouldn't take long. This is just one equation that we need to learn, um, and it's something that you can kind of physically see and physically do, as opposed to some of these things which you might not be able to see necessarily. This combination stuff is a little bit more visible to you. Okay, so today, actually, one more note on the final. Okay, again, that practice test is in your email and it's in on campus under the topic sequences and series. Your final is going to look probably about 90% of what I emailed you. All right. There might be one or two questions that I tweak, but overall, it's about that. All right. Some of them are really, really simple, like is it arithmetic or geometric? And if so, like find the 10th term. All right. So that's just applying an equation and seeing if you know the difference between arithmetic and geometric. All right. But your final, I still haven't decided on like the time frame I want to do it. I'm leaning toward giving like a 2 to 3 hour period of you getting that done. And I'll have different versions of it and stuff too. So, but my guess is that on Monday or Tuesday, I will assign it. You will have 2 to 3 hours to do it, take a picture of it, and send it in. Again, I'm not decided on that yet. I might give it to you like Sunday night and expect it like Monday at noon or something. I'm talking to a couple other people to see what they're doing, but that's kind of where I'm headed. All right. Final grades are due on the 12th, and anything that's not turned in by the 6th is considered a zero. All right. So you have until the 6th. If you have any late work that you need to get done, the 6th is that deadline. Okay. So in between now and the 6th, we have the test, quote unquote test, and late work to be done. All right. And if you have questions about that later, we can go over it. That'll be more something for teams. Okay. But moving on to today. All right. So I want to first kind of quickly go over what we've covered so far, and this up on your screen pretty much covers it, except for like really what a sequence is. But we should know about what that about that definition now that we're this far. Okay. So we've covered what a sequence is, and kind of the different patterns and a little bit about how to map the nth term. All right. And then we've gone over two different types of sequences. We've gone over arithmetic and we've gone over geometric. Okay. So arithmetic, we need to be able to find the nth term using this equation. So an arithmetic sequence is something where you're just adding a certain term over and over again. Okay. And that constant term, that is our common difference. And once you find the common difference and the first term, you should be able to get both of these things. All right, so we need to be able to sum them, and we need to be able to find the nth term. Okay, and you've had homework over all this. We've also covered geometric, which has two different scenarios. There are finite geometric sequences and infinite geometric sequences. For both, we need to be able to find the nth term. Okay, in order to find the nth term, you need the common ratio, which is the ratio between two consecutive terms, and that's constant throughout. And you need the first term. In order to sum them, you need the two same pieces of information. You need the first term and the common ratio. You plug it into this equation, and you get an answer. That's if it's finite. Okay. The other scenario is infinite. So if your common ratio is less than 1, you can find the sum of an infinite geometric sequence by plugging it into this equation. And again, you need the same two pieces of information. You need the first term and the common ratio. And then when you have that, you plug it into that equation and you get an answer. I had a couple questions in on campus that were asking why, when I just add the fractions together, don't I get the answer? On IXL, in the first like 40 points or so, it gave you like 1/5 plus 1/10 plus 1/20 or whatever. You're not adding those fractions. Okay. You are adding that pattern up until infinity. Okay. And in order to do that, use this equation. Okay. So I'm not sure where people were confused about that, but it's all about this equation in green for that last night's homework. All right. Really, besides that, I don't see any other questions. Again, not that it matters from here on out, but this really only works if you actually do the homework kind of before class. So if you do have questions, I can plan around it. All right. Maybe that's definitely going to be a lesson going on into college, because you're actually going to have to finish stuff before class. Okay. But hopefully we understand that. Besides the arithmetic and geometric sequences, there's a little legend for what a sum actually means. So there's the upper limit, the lower limit, the sequence, and what all that means. And then we also went over factorials. Okay. Which this will come in handy in this class. Okay. So today we're going to cover the final thing that'll be on the test. All right. And that is combinations. So what is a combination? All right. A combination, and this gets into counting principles, which we're not going to be able to get into. If we were getting into probability, this would be one of the most important things that you can know. But as of right now, this is just going to be kind of a plug and chug. But I want you to understand what it's actually saying. So combinations of n elements taken, there should be an R right here, taken R at a time. What that means is you have some number of total things, and you're choosing some smaller number of them. Okay, so if there are like 15 people in a class and I choose 5, that would be 15 choose 5. Right? So 15 would be the number of n elements. 5 would be R at a time. Okay, so n is the total number of things. And R is the number of things you're choosing. Okay, so like a very basic example of what a combination actually is, now that we have a little bit of terminology to work with. In how many different ways can 3 letters be chosen from letters A, B, C, D, and E? What do you mean by you're going to give us our final Monday or Tuesday? Are we not taking it on Thursday? Well, I want to be able to have a chance to review it. I'll get into that later. We can talk about that on Teams in a minute. This is the last thing we need to go over. Okay, so just hang on for anything else. All right. And how many different ways can you choose 3 letters from A, B, C, D, and E? Okay, so we are choosing 3 things. So 3 is our R, and we have 5 elements to choose from. Okay, so in order to do this kind of without any calculation, we can list the number of different ways that's possible. Okay, so we would choose A first, and then we would choose 2 different ones. So to keep it consistent and kind of have a rule, like have a sequence of this, we would choose A, B, C. Again, we would keep A the same. Then we could choose A, B, D. And then we could choose A, B, E. And then after that, we could change the B. So we would have ACD, ADE, or ACE. And then we can change the C to get ADE. All right, and then after we keep the A's all the same, we could keep the B's in front. So we would have BCD, then we'd have BDE, and then we would have BCE. And then again, after we keep all the B's the same, we would have C, and we would have CD. Okay, so I'm not expecting you to be able to do this. I'm just trying to get people to understand like what's actually happening. What are we actually talking about? Okay, so everything that I have up on the screen in blue, green, and red, those are all of the different combinations of 3 letters given the 5 letters that we're trying to choose from. Okay, so if we just count those out, there are 10 total different combinations of that. Okay, so that's like the really hard way to do it, is to just list them. It is possible, but it is a little bit time consuming, especially if you're not used to doing it in a sequence. All right. The other way that we can look at this is using a combination. Okay, so we have 5 different elements, and we are trying to choose 3 of them. Okay, so mathematically we can say 5 choose 3. That's the number of elements we're trying to get. Okay, and what that comes down to, all right, so this is this 5 choose 3. That's how we're going to talk about things like this. And in order to calculate that, we have a general definition. Okay, and that general definition is given n elements, and we want to choose r of them. We have n factorial divided by n minus r factorial times r factorial. Okay, so this is our equation. Okay, this is what we're going to have to be plugging stuff into. So given 5 choose 3, if we plug that in, we get 5 factorial divided by 5 minus 3 factorial times 3 factorial. And if we actually do that, if we expand that, 5 factorial is 1 times 2 times 3 times 4 times 5. 5 minus 3 is 2, and then that's 2 factorial, so that's just 1 times 2. And then 3 factorial is 1 times 2 times 3. Okay, so what ends up happening is if we simplify this, we can cancel out common terms. So we get 20 over 2 which is equal to 10, which is the same answer that we got above. Okay, so again, if you just plug in numbers, plug it into a calculator, and hit enter, you're going to get the answer. All right, so why is this actually important? This comes into play in probability, which obviously we're not going to get to. But what probability is, the most important part is finding a sample space. So the number of different ways something can happen. And this is one of the most important things we can know, is find combinations of stuff. Okay, so for example, playing poker. Okay, in poker, in one deck, there are 52 cards. Each hand is 5 cards big. So in order to understand kind of how many different hands are possible, and maybe calculating your probability of getting that, we want to choose 5 cards from 52. All right, so in this case, N would be our 52, R would be our 5, and we would do 52, choose 5. So again, if we just plug that into our equation, we would have 52 factorial over 52 minus 5 factorial, which just ends up being 47 factorial, times 5 factorial. And then we can calculate that. So we can do this really easily if we know what factorial actually means. So 52 factorial over 47 factorial. We can rewrite 52 factorial as 1 times 2 all the way up to 52. And then we can do the same thing for 47 factorial and 5 factorial. And then we can cancel out common terms. So on the top, 1 through 47 will cancel, this 1 through 47. And then we have 48 times 49 times 50 times 51 times 52 over 5 factorial. And if we plug that into a calculator, we get this gigantic number over 5 factorial, which is 120. And if we divide those two, we get that there are 2,598,960 different hands in poker. Okay. And again, this is most important in probability, but it's a good counting principle that you can just know. All right. So really, that's it. All right. We just need to know this equation and choose R is equal to n factorial over n minus r factorial times r factorial. Okay, and everything else that we did is just kind of explaining what that actually means. Okay, so that's all I have for you. that's like the last bit that I wanted to cover, and it's not hard. It's just plugging numbers in. Okay. There is no homework, but I do want you to actually do that practice test before Thursday. All right, because then we can talk about it a little bit, and then we can talk about how we want to take this test. All right. So with that being said, I'm going to leave this open for a couple of minutes. After that, I will start a meeting on Teams. So if you want to work on that practice test and kind of ask for help, you're welcome to. But otherwise, that's what we have going. All right. So again, I'll leave this open for a couple minutes. General questions here, specific questions a little bit later on in Teams. So what day is our final? I'm still like trying to figure that out. I'd like to be able to talk about this and actually have a class period to talk about it, and then we can take the final next week when people are a little bit more prepared for it. Again, I'm thinking like Monday or Tuesday. Wednesday can't happen, and everything else after Wednesday can't happen. But I would like you to have this and try it, and then us talk about it, and then have it Monday or Tuesday. So no test Thursday and just final next week. Yeah, that's again, if yeah, that's what I'm planning. So let's talk about this practice test on Thursday, and then have the final on Monday or Tuesday. And again, the final wouldn't be like you show up to class and do it. It'd be like you download a PDF, you do the questions, and then you just take a picture and turn it in. So I'm not like requiring attendance or anything, but you would have to get it done in a time frame. I know your last day is Thursday. So that's where I would point you to the practice test. Um, Again, the final is only covering what we've done in this chapter. So it doesn't cover matrices, it doesn't cover trig. It's literally just what we've done with sequences. Okay, so I'm going to close this, and then I will see you in Teams here in the next minute. Okay, but please actually do the practice test before Thursday. So again, we can talk about it and actually get any questions out of the way that you have. So again, I'll see you in a minute on Teams.